In this tutorial, we're going to cover how to build a three-dimensional site using GIS data in Rhino3D. So we're going to need a few things to do that. First, I'm just going to go to the browser here. One thing we're going to need is a plugin for Grasshopper. Grasshopper is a plugin for Rhino. It's part of Rhino 6 now, but it's called Meerkat. And if I go to Food for Rhino, that's foodforrhino.com, I can find this plugin really easily. You'll need to make an account, but it's free to download. So go to Meerkat GIS. I'm going to go to the download section. And when this video is being filmed, actually, the latest version was from 2015. It works fine. So I can download this file here. And I'm going to need that. We're going to have to do a little bit of work with that to get that installed. The other thing we'll need is GIS data. There's a few websites to get that. One is Open Data Philly. You can come in and look for specific pieces of data here. There's all kinds of maps and data sets and spreadsheets just to tell us a little bit more about the city. Sometimes I have problems getting shapefiles downloaded. I think it's probably just a browser problem. But there's also the PASDA, which is actually hosted by Penn State. And it's a collection of shapefiles and GIS data from all over. So these are the Philadelphia resources. And within this, I searched and using Control F, and I can find three-dimensional buildings, right? So here is the 2017 edition of Philadelphia buildings. There are other models here. And when I click on this, I can learn a little bit more, and I could actually go in further and see kind of what data is included in this file. I think this one's going to work just fine for us. Here's all layers and tables. Let's see if we can see if there's any data that jumps out. So here we see the shape of that building, its base height and its average height and its max height. And really that's all we're going to need. It's not going to be an overly nuanced model, but you don't even really have to dig that far into these files. You can kind of just grab them and through the software see if it's what you need, and if not, come back and grab another one. There's contours here, so this will help us generate the terrain of the site. And I also downloaded curb lines. I think the last one I did was parks. I forget the name, playgrounds. It was Philadelphia Playgrounds. So these are the files I downloaded. And when I get all of that, when I get Meerkat and everything else downloaded, you can see I've unzipped the GIS files, and they've become folders here. Meerkat itself is a zip file, but because we're going to be installing it on our computers and using it as a plugin, Windows especially has a security feature. So I'm going to go to its properties, and you can see here it says that it came from another computer and might be blocked to help protect. I know that that file is safe, so I'm going to unblock this zip file. And in doing that, then when I unzip this here to Meerkat, I have a few files in here. This is the README. If you did not unblock the zip, you're going to have to come in and unblock each file that you see here. That's the only way to get it installed. So once you've done that bit of legwork, once you've downloaded Meerkat and unblocked it, once you've downloaded the GIS, we can jump over to Rhino. And in Rhino, we need to launch Grasshopper and use Grasshopper to install Meerkat. So I can go to Grasshopper, and now I already have it installed, but if you don't have Meerkat installed, you can go to File, Special Folders, and Components folder. That will bring up the libraries for Grasshopper. You can see I have a lot of plugins in there. Part of that is Meerkat and those DLL files here. So if I really needed to, I could grab all of this stuff, copy it, and paste it into my special libraries here. Once you've pasted that, it's installed, but you need to restart Rhino for that plugin to show up. And when you do, it'll be under Extras. So here's Extras, and here's Meerkat. All right, that's all the kind of the background legwork that needs to get done. Now we're going to use those files to build a three-dimensional model of any given portion of the city. So this is a tool that, maybe it takes a half hour or so to generate, but once you have it generated, it's useful in perpetuity. You can use it again and again and again for all different types of data, for all different sites all over the world. And the first thing we have to do is to import a shapefile. So here under Meerkat, I'm just going to click that menu and then import shapefile. And when I do that, let's see, there's shapefile here. I can drop it on my canvas, right? So if you've never used Grasshopper before, I can use right click to pan around. I can use my mouse to zoom in and out. I can left click on a node to move it around. And you can watch, there's other videos available on kind of just the fundamentals of Grasshopper, but I'll walk you through here. So this little node is kind of a terminal thing. We're going to convert a GIS shapefile into a Meerkat file. It's just parsing data for Meerkat to use. And to do that, we have to like trigger an action. So I'm going to double click, and when you double click, you can search for components. And I'm double clicking and just searching for the button component. The button component is a really easy component, and I'm going to drag out of that little node and connect these two wires. So now if I click this button, this component will run. So click, and this is the parser. So this is just a Google map view. This is Seattle, Washington, which is where Rhino is from. I'm going to add my shapefiles by clicking the Add Shapefile button here, and then on my desktop there's GIS data, and I want to add these shapefiles. So let's start with the buildings. This is the buildings, and I'm going to add another shapefile, and that's the contours, and add another shapefile, the playgrounds, and add one last shapefile, and that's the street curb lines. And you can see as soon as I click one of these, my map will update to show, this is the bounds of that data. So there we go. You can see there's a few different boundaries, right? And so if I was working with a different shapefile in a different city and a different nation maybe, this map would update to show where the data is contained. So with that, let's just jump in. We can say down here, kind of the Grays Ferry area. And I can actually even change this window. And I'm going to crop this, right? We do not need every single piece of data for all of Philadelphia. I'm only really interested in generating a site model of this zone. So I can click here, the draw rectangle, and then I can just drag out a rectangle of the area I want my file to be. I'm going to include up here the cemetery, which is one of my favorite places in the city. So there we go. And I'll click crop shapefile. And I have to put it somewhere. So again, on the desktop, I have a GIS data, so I'll put it all in the GIS data here, and I'll say OK. Now, this will take a couple seconds, and the bigger you make your box and the more data sets you have, the longer it will take. And unfortunately, it doesn't really give you a notice or some kind of spinning wheel or anything. The thing that I noticed is that my Grasshopper kind of closeout window turned red without me touching it, and then it went back to normal. And that's my sign that it worked its way through the data sets and it's actually parsed everything. So if I go here to my desktop, GIS data, I can see that there's MKGIS, that's Meerkat GIS files. So it's made all four, and they're various sizes here. So I know it's done and I can close this. It didn't take all that long, but you really don't want to just close it while it's making those files. All right, so that's step one. This is all we needed that for. The next thing we need to do is to parse that Meerkat file, right? So I'm going to take and parse Meerkat and drag this out. There's a lot of information here, but again, it's looking for you to plug in one thing. And if I hover over this, it says connect an MKGIS file path. All right, so over on the left-hand side, I'll type file path, and I can get the file path node. Anytime you see a black hexagon, that means it's an input node. It's something I can put data into. So there's my file path. I'll connect these two together. And then I'm going to right-click file path and set one existing file. Same thing as before. We'll go to GIS data, and I'm looking for my MKGIS files. Let's first start with the buildings. These are the 2017 buildings. We'll say open. It should think a second, and when you see it change from orange to gray, that means it's functioning. It's got all the data, it's pulled it through, it's parsed it out. If you saw it turn red, that means that the Meerkat file is not functional, it's not operable, or maybe you put something wrong in here. Maybe you put a JPEG or an Illustrator file. That won't work with this node. Orange means warning, gray means it's working. So out of the other side of this, I can get some information. So I'll double click and use a quotation mark to get what's called a panel. I can hit enter, and I can just check, here's the date that's cropped, today, the 2nd of September. File path, I could look at that, and you can see there's where the file lives. But really, all of this data exists in my Rhino model. So let's see if I zoom way out. Put this back. I can't find it. And the reason for that is that this may be parsed incredibly far from the origin. We could be miles and miles and miles away in Rhino. But thankfully, this data file has a bounds in point space. We're not interested in the lat-long space, that's latitude and longitude. We're interested in the bounds and point space. So here, we're in Rhino, this is point space, and this is a containing rectangle. So it's the absolute perimeter of the thing that we cropped. And the nice thing with that is I can actually measure the area of that rectangle. So I'm going to use the area component, get the bounds and connect them. And when I take an area, I get A, the area, and B, the centroid. The centroid lives at the very middle center of that rectangle. So with that data, I can actually move everything. And to move that, I'm going to make a vector. You maybe remember vectors from geometry class. A vector here, I'm going to use a 2-point vector. And that vector is a direction and a magnitude. So if I start my vector from the centroid of my bounds, I want to make my second point the origin of my Rhino model. So to do that, I'm going to get an XYZ construct point. Here you go, construct point. Right now, you can see this point is right here. It's at the origin, 0, 0, 0. And I can zoom in, you can see it there. I haven't changed any of the X, Y, and Z. They come default set to 0. So if I right-click X, set number, there it's 0. So if I plug that into B, this vector now is invisible, but it's essentially connecting the centroid of my data somewhere out in space to the origin. And with that, I can then tell that data to move, and using the move component, I am going to move the geometry per shape. So this is the actual geometry. I'm moving that data by this vector. So when I plug that in, you can see here now there's all of these points. These are all just singular vertices, but I've moved them from somewhere randomly out in space so that the center of them is about my origin. Now, as this kind of continues to build, it'll get a little messy. So what I recommend doing is just dragging a window over these nodes, right-clicking, and turning off their preview. We don't care to see them. Here we see those vertices, and that's all well and good. We can look at them in 3D, but the fact of the matter is that we care about kind of their connection, not really the vertexes themselves. So to connect them, I'm going to use a polyline. And so by typing polyline here, I'm going to connect these vertices into this vertex point. Now, you'll see like, oh, well, there's so many vertices. How does it know? The way this GIS file is set up is that each of these buildings is uniquely indexed, right? So this would be building 0, this would be building 1, this would be building 2. And Grasshopper is smart enough to know that when we're connecting this geometry, these vertexes, it's not going to try to connect vertex from building 0 to vertex at building 1. It's going to stay self-contained. So I can drag the geometry we moved into these vertexes, and you can see it's then generated each of those kind of polylines. And we're going to make sure that under our polyline component here, I can right-click the C and make sure that's set to true so that it's a closed polyline. This is how we make sure that it is actually sealed up. Similarly, I can then right-click on move, and if I click the very center of the word move, I can right-click and unpreview it, and we're left with just those polylines. And the next thing we want to do is to extrude these buildings, right? Right now they're just flat portions of site. And thankfully, the GIS file has that data. So let's double-click again and get a quotation mark so that we can pull up a panel. And if we look here, we have the field names. So let's connect the field names. And what this says is that in each piece of geometry, so we have a shape and that shape has geometry, we have a shape and it has a field value. In those field values, the item 0 is the area, item 1 is the base height, the average height, the max height. We have some shape area and the shape length. And so what we're going to want to do is extrude our buildings so that they go up to either the average or the max height. I'm going to use the average height. I don't really care that they're all coming from a 0, 0 point because ultimately my buildings will extrude all the way up to that maximum height, and my contour, my terrain, will cut through them. So we won't actually see the buildings being taller than they need be because our terrain will be elevated up. So if I'm going to extrude these things, I'm going to double click and use extrude. What are we extruding? So the B is the base geometry and the D is the direction. So the base geometry are our polylines. The direction, it doesn't know which way to go right now. So if I double click, I know that my buildings are going to extrude in the Z direction. So I'll type Z and I'll use unit Z and I'll connect that. And we'll give it a second to think. It's got a lot of extruding to do. And there we go. It's thinking. All right. And a couple seconds later, you can see we have little tiny extrusions because we've only extruded each of those footprints 1 foot. And I know that because I'm working in a Rhino unit of feet. And right now this force of that extrusion is 1. So what we want to do is to pull from our field values. And if we look at another panel here, our field values here are per shape, and we see all of that data, right? So I want to come in and tell this list of data that we're only interested in list number 2, average height of 20, average height of 21. And to do that, I'm going to get a list item component. The list item component I can pull either from this field value here and plug that into my list, but you can also pass lists from a panel into the list. So this is probably a nice way to do it. And this one is where we index. So I don't want item 0, I don't want item 1, I want item 2. So I can right click I and set the integer as 2. So now it's only going to pass, and I'll copy and paste this panel so we can look at it. It's only passing item number 2. So here we have 20, and then we have 21. There's 20, 21. And each of those is referred to as item 0 of its own independent list. Those items there then go into my factor for the extrusion. Again, it needs to think, so we're going to give it 1 second. All right, maybe 20 seconds later, you can see now I have deep, tall buildings. And one special thing we are going to want is to cap this. So I'm going to double click and type cap. And I'm going to cap the holes. So I'll plug my extrusions into cap. This will put a top and bottom on all of these geometries and kind of make one single solitary kind of unified solid. And then I'm going to want to come back and unpreview all of this legwork we did and just keep just the cap is previewed. We'll see all of those buildings throughout the city. The larger your GIS file is, the kind of more horsepower the computer needs to make this work. And so you just be patient. Know that after a minute or two, it'll probably get the job done. And it's important to probably save often. So let's do that right now. I'm going to save this document. I'm going to put it on my desktop under GIS, and we'll call this the site maker. We'll save that. So here, the cap portion's the important part that I want. All of this stuff back here, I'm going to right click and preview off. And when I do that, I can minimize Grasshopper, and I can just take a look, and I can see the University of Pennsylvania Hospital campus here is a lot taller. A lot of the row houses over in the city are lower in height. It makes a lot of sense. But that's not all we need. We also need roads and playgrounds and other things. And so the reason for building this with Grasshopper is that we can continue to use this document again and again. So the first thing, just to simplify things, I'm going to first bake these buildings out, right? We want to move them into Rhino. So to do that, I'm going to go, for some reason my layers aren't open. There's my layers. My layer 1 here is going to be buildings. So the interesting thing about Grasshopper is that we can preview it in Rhino, but actually I can't click it. It's not there. It's only existing in Rhino. So here when I click that node, it turns green. I can zoom in and right-click cap and bake this. I'm going to bake it onto the buildings layer, and I'm going to make it a group. So say OK. And a couple seconds later, we'll see that in Rhino, we'll have a copy of that data. You can see it there. So if I close Grasshopper, now I actually have physical geometry in Rhino, and I can go to shaded view in Rhino so that we can see this. And again, this is a very large site file, so you have to give some patience. And this is a physical Rhino object, so I can do whatever I need to do to it. I can change, manipulate, I can ungroup it, delete portions of it, depending on what I want to do with my site. Once I've done that, let's go back to Rhino, or to Grasshopper, and I'm going to disable all of this data because I'm going to copy and paste it. I don't want to make a second one. So with all that, I'm going to copy and paste. Copying, pasting while it's active would just mean that it's going to try to rebuild everything all again. And we don't want to do that. So this time, we're going to come in and actually change our file path and set up, this time let's do curbs. Curb lines here. So when I open that, and I can enable this, but curb lines aren't something that we're going to extrude, right? So we're never going to, we're just going to use those flat lines. So I can delete some of this stuff, and then I can re-enable these components so that it didn't take time to calculate things that we didn't need. So this works the exact same way, right? We bring our curb lines in, we parse them, we get the area of them, we make a vector, we move them. These are the moved points. I'll preview those. You can see there. And then I can make a polyline, or I can use and interpolate. And if I interpolate a curve, that might be a better representation because some of our roads are not polylines. They're nice smooth curves, right? And so that quickly, well, it took 20 minutes or so to get this portion here. It took a few minutes just to get the polylines of the roads. So here under buildings, I can call this roads. I'm going to right click this and bake it onto my roads. I'll make it a group and I'll say OK. Now the roads are tricky, right? I'm going to close some of them here, like, oof, clearly not good. We do not, that is not a nice looking road. So let's, maybe we'll delete these, bring Grasshopper back up. And let's look at the difference between that and a polyline. So right click this and I'll unpreview it. The polylines seem to be better for these kind of inner blocks. It still gets a round corner on the corner of the street. Some spots here where we have overpasses and underpasses, it gets a little tricky, but let's use polylines instead of curves. So this is our roads. We'll bake that. We'll say OK. If we go, and we're going to continue to build the contours, the real trick of this is always using these polylines to split the contours. So I'll show you that in a second. Let's delete that. This one I'm not going to worry about enable, disable because it's super lightweight. And then I'm going to take this polyline. This time we're going to set this copy paste version and we're going to get the contours. So here's the contours. This one, again, we've got to think about this because it's going to have a lot. I downloaded the 2-foot contours. There's also 10-foot contours available, but 2-foot contours means that we're going to have a much closer approximation to the physical terrain. It just takes a lot more time to move. So here we go. We move them. And again, we have all of these different points all over the place. If I wanted to, I can interpolate a curve through these points. So those are those curves. And the trick we have here is that we need to move these points once again up into a Z position. So if we look at our list here, we have the elevation is number 6. So I'm going to move, actually, I'm not going to even use these curves. I'm going to move these points. I'm going to get a list item. This time my list item is going to be set to number 6. So from the data list, I'm going to pull that into the list, and I'm getting item number 6. Item number 6 is my elevation. I'm going to put that into a Z vector, and that Z vector is where I move those points up in space. So you can see now all of those vertexes are moved up to essentially the height of that contour wherever it exists. So I'm going to grab this stuff and turn its preview off. I'm going to save this file, right? This is where we get really tricky. It can be hard. I'm also going to save this Rhino file. So on my desktop, GIS data, Philly site file. There we go. And I'm going to use these vertexes. It's going to think for a second. All right, so it saved everything. That's good. I'm going to use these vertexes to create a patch surface. A patch surface is kind of a very free surface. It can move in any direction. But right now, I'm going to be feeding it 489,000 points. That's a lot. So let's see. There's one thing that I know, and if I look at this patch, it creates a free patch surface, and I expect this is going to take a long time. So we can feed it curves, or we can feed it points. And right now, all of these points, remember, were hierarchical. They were organized by given pieces of geometry. And we don't want that hierarchy anymore because we've moved them up into their correct elevations, which we can view here, actually, in the front. You can see here, there's all the network there. I'm going to flatten this data, and that means that it's no longer associated with a given shape. It's just all uniformly equally important floating points. So we'll flatten that data, and by flattening it, it's telling the patch to use all of them instead of trying to build individual patch surfaces. So I'm going to plug this in, and it's going to take a few minutes, so I'll pause the video and we'll look at what comes out on the other side. All right, and surprisingly, maybe 30 seconds go by, and I have now a topographic site. I can unpreview my move here. I don't really care about that. What I do care about is this surface. And you can see the surface is bigger than the site we picked, right? It's going to have like some containment and bounds. So let's put this as contours, and I'll bake this patch surface to my contour layer. I'll say OK. And then I can close. And you can see here, the one trick we have is that some of these buildings are low, right? So where some of them work just fine, some of our row homes, we didn't set the base of that extrusion to come up above the topography. So we're going to have to rebuild the buildings. So let's just make another layer here. Buildings version 2. And this is a problem we can easily solve. So I'll go back to my shaded view, go back to Grasshopper. Remember all of this stuff I had unenabled because I was copying and pasting it, so we'll enable it again. And our extrusions, our polylines, what we're going to want is to set our base of our polylines up to our base elevation and then to extrude it based on its average height. So once this thing thinks through that process of rebuilding all of that in Grasshopper, we're just going to do the same thing we did with the elevations, move our polylines up to a set list of the base height, and then we'll use our extrusion from there. All right, and you can see why this is important to kind of always save as you iterate on this. It can really bog down and sometimes crash. So what we're going to want to do is then to move with, again, this was an extrusion that we were doing, but we're first going to move our Z. And so our base height is list 1. So really I can just copy and paste this list item. I'm going to change this new copy to be list 1. That's going to go into my Z. I'm going to move my polylines up to that Z. And I'll slide this over. I'll slide this over. And so our polylines have now moved up, and that is what we're going to extrude. We're not going to extrude our base flat polylines. We're going to extrude our moved polylines. And again, it's going to take a second to think through everything. But what we'll have are three-dimensional buildings where their kind of ground floor is much closer to the location of the contour, so the elevation of the city at that point. All right, so 30 seconds later then, I can kind of shift some of this stuff around so it makes a little bit more sense. Those were our base polylines. We move them up the Z. I'll unpreview that. We then get our extrusion heights to our average height of the building. We extrude that and we cap those buildings. So if I right click these and bake, these are going to be buildings version 2, and we'll group them. We'll say OK. It's got to push a lot of buildings over into Rhino, so we're waiting to see when we see an ISO curve on one of these, we'll know that it's actually a Rhino object instead of a Grasshopper object. We also have our friend the spinning wheel here, and there we go. So let's close Grasshopper again. When I close this, it doesn't actually cancel anything, it just stops previewing. And so here I can go into rendered view, and now you can see our buildings are actually sitting up on the terrain. It's pretty close. It's not perfect. Some of them are, could be a little bit taller. And if I really wanted to get picky, I could go into Grasshopper and I could take my base height. I could subtract 4 or 5 feet and set that and then extrude from there. But I think for our purposes, this should work just fine. Let's see here. Looking for, there's our curves. So this one again, we built our curb lines, and our curbs are sitting below the earth, right? So here we can see that our contour is bent there. Here we can see our curves just fine. And so this time with our roads, I'm going to make another sublayer here and call these projected. And so what I want to do is to take those curves in Rhino, this isn't a Grasshopper thing, and I'm just going to use the command project, and I'm projecting all of those lines up onto my topo surface here. Again, we're working with huge pieces of data, right? So this one Rhino file probably has more lines, curves, and polysurfaces than any file you've worked with in the past, so you have to give it a little bit of time to figure things out. I've also built like a pretty big portion of the city, and if I wanted to work with something smaller, obviously it'd be faster. So these now projected up, and I'm going to make sure I don't have anything selected, and I'll use SEL last, that's select last, just to make sure that I'm selecting the projected geometry. This thing I'll group, and then I'll right click my projected layer and change that object layer. To do that, I'm going to actually kick that back out so that way I can turn off my roads underneath. And if we look at this in rendered view, you can see now that those streets, those curb lines, and we'll put north up, those street lines actually projected up onto that surface, and that's an important part of making sure this works. All right, final step, let's look one more time. So again, all of this stuff, I'm going to come over all of it, I'm going to right click and unpreview it. I don't want to see it. Here we had that, this was the patch surface. And so I'm going to do the same technique that I did before. I'm going to grab all of this, I'm going to right click somewhere in the negative space, but within that bounding rectangle, and I'm going to disable it. I'm going to copy and paste it and move this down. I don't want to be patching anything as I put in new data. So this time I'm going to right click, set one existing file. I'm going to put in the playgrounds. We'll say OK. So now I can enable all of this by grabbing it all, right clicking and going to enable. And so we can see what's in here. We have the address, the age, and the site. So intended age, int. So 2 to 12, 2 to 12, 5 to 12. And let's see if we can see what we get here. We have not even boundaries of these parks, but simply just a node, right? So out of this, I don't get to see an outline of that park, but what this is telling me is where those parks exist. And so this data, although isn't really helpful to kind of create spaces, I can use this to help me visualize and understand what's there. So to do that, I'm going to use a text tag right here, text tag. Actually here, even better, 3D text tag. The 3D text is going to be the location, and so that's going to be our geometry here. Our tag, which will be our text, is the same thing we've done before. We want the list item. I don't care about tagging it with its proper address, but I do want its name, so I'm going to right-click, set integer to 2. So I know that the site is the number 2, and I see Clark Park's on list 2. So this is our text. So I plug this into our text. And then our size, right now this will be 1 foot. So I think this is showing up. Let's see. There it is. I saw a little bit of text is really small. So let's look at the other options here. Size, color, and justification. So we can change our size. This time I'm going to say I want maybe 11. And what this will do is give me a number slider that goes from 0 to 100. And I can set the size by this slider. We're closer, but it's because our tags are underneath the earth. So let's just move everything. All our tags are going to move in the Z direction. Same thing, we're going to use a slider. So I'll copy and paste that here. This is up that way. We're moving these tags up and there. So I did that really quick, but essentially what I've done is move my vertex point up into space, and so then that would become our text tag here. And I can move that further up so that we're always above the terrain. So maybe it's 100 feet up, and I can make my tag even bigger. And that way here, there's one last thing I can try. Right now this text is just presuming that it should be laying flat, which might work, but I'm going to use what's called an XZ plane. So an XZ plane is along the x-axis but is a vertical plane. So if I plug my points into the XZ plane and plug that into the location, it should rotate, and there it did. It rotates the text so that it sits along that plane. So similarly, I grab all this stuff, right-click, unpreview. These text tags I can bake, but maybe they're just a nice helpful thing here. Let's go here. I'll go text. Right-click this and bake our text tags here. We'll group them again. And then see if we can close Grasshopper. And there we go. So as I move around, you can see I have 3D text within our map just to help us understand. So that's it. That's a kind of quick overview of reconstructing what we did in class. The files for the GIS data that we used here and a link to Meerkat are located below the video, so you're welcome to grab those. This is just the start, right? This is the base. You can always get more shape files. You can get additional data. We can transform a lot of city data to make this a more and more compelling site model. I can even come in and say that I want to split my topography with one of my curb lines. This is a big group, so I'm going to actually ungroup it so that it doesn't take forever. So to get this group, ungroup, then my topography here split with this one single curve. Oh, it doesn't look like it was closed. Let's see if now, yeah. So now I have this one single piece, and I could always change its kind of color. In fact, I'd want to change its shading. But if I needed to, I could come in and split my contour model with individual streets so that I could generate each of the kind of sites. It takes a little bit of work, but I don't know of an easier way to build site context in kind of a parametric way. If we jump back to Grasshopper, we can save this document one more time. So for any project in the future, I would just need to go through the process of making my Meerkat files and plugging them in.